This is a study video for April 2020 end of semester test for Miss Morris's math class at FSCJ. You all have been so diligent in working through these very difficult times, and I just want to commend you for that. I'm so proud of you all. And these are just some random thoughts as I've looked over these tests that I was given to administer to you. These are just going to be some things that might help you with the test, some things that you should think about before you take your test. But don't stress over this test. Just for the fact that you're going to take the test, you're going to get a satisfactory progress in this class. And if you get a 70% or above, you will get an S for the class, a satisfactory for the class that you were in. So if you were at a level B and you pass it with 70% or above, you will get an S, a completion for that class. And the next semester you would sign up for the level C, which you could take that again with me, or you could have it with another teacher whenever you choose to come back. So enough of that said, so don't stress over that. But here are some thoughts. And I'm trying to cover a whole lot, so some of this is going to be on a D level test. So the folks who are taking a B or a C may not see some of these things, and but you'll see them later on. So anyway, here goes. So some things to think about. Be sure that you read all the charts and the graphs completely and paying attention to details. Read all of the answer choices. One or two questions may have two correct answers. So that only happens on one or two questions that I think I saw on the on the C and the D level test that I will give out. But don't stress over that if you don't find it. Number 3, if you don't have a clue as to then I want you to use the old Sesame Street quote of one of these things is not like the other, and choose that answer. That's just a good fallback if you don't have any other option. I want to go over a few definitions of words with you. Mean, it's the same thing as average, and you can add and divide by the total number of items. So you would add all of your data points, whether they were your grades, and then if you had 7 grades, you add them all up, you total them all up, and then you divide that total number by the number 7, and that will give you the average or the mean of your data. The median, that means smack dab in the middle, just like the median in the highway. So you want to first order the data from the smallest to the largest, and then you want to find the one that is in the middle. So for instance, if you had 7 pieces of data, the middle point would be the 4th one. But if you had 6 pieces of data, you don't have a perfect middle. You would have the 3rd one and the 4th piece of data. So what you would have to do, if you have 2 that fall in the middle, add those 2 pieces of data together. If they happen to be the number 26 and the number 27, you would add them together, and then you will divide by the number 2, and that will give you the answer of your specific middle piece of data. Okay, the mode, that is the one relating to the word most. If you'll remember the MO of mode and the MO of most, that should help you. And that is the piece of data that occurs the most often. It repeats the most often. Some data will not have a mode if you don't have a duplicate of one of the pieces of data. All right, leaving those pieces terms, we go to factor. And factor is a word that means it divides evenly into another number. So 5 is a factor of 30. 5 is not a factor of 8. 5 will not divide evenly into 8. GCF stands for greatest common factor. That means it's the largest number that divides evenly into 2 or more numbers. So for instance, if I said, what's the greatest common factor of 10 and 15, you would have to say it would be the number 5. If I said, what's the greatest common factor of 8 And 16, you'd want to say that it's the number 8. 8 will go into the 8 one time, and it'll go into the 16 two times. A factor pair is two numbers that multiply together to equal a larger number. For instance, 2 and 5 are a factor pair of the number 10 because 2 times 5 equals 10. That's all a factor pair is. All right. There are some terms called transformations. Some of you may not have gotten to that, but there was a little bit on the IXL program that talked about transformations. So these are important terms. Rotation, just like it sounds, it turns around a fixed point. So if you have a picture of a triangle and it turns, and instead of having its point facing up, now its point is facing to the side, that may have been a turn around a fixed point. So that would be considered a rotation. A reflection is going to be a mirror image of something. So just like you would see yourself in the mirror, things are a little bit reversed, you know, so be aware of that. Translation, that's just a fancy word for a slide. You could slide something up, you could slide something down, you could slide something diagonally, you could slide it sideways, so it's just a slide. And then dilation is bigger or smaller, so if you start with a small triangle and the same ratio of triangle, but it's just larger on another space of the drawing, then that would be a dilation. Your pupils get dilated at the eye doctor, they get larger at the eye doctor. Okay, now I want to move into formulas for shapes, because you will be asked some stuff, at least on the C and D and maybe even on the B test. Perimeter, you need to know that perimeter, all you're doing is you're adding up the length around the outside of the shape. So for instance, this is kind of an odd looking shape, maybe like a pencil. So I've got one end of it is, say, 2 feet long. These two sides are both 3 feet long, and then these pointy parts are each 1 foot long, or whatever measurement I'm using. So then you just add them all up. 3 plus 3 is 6, plus 2 is 7, 8, plus another 2 gets me to 10. So the perimeter of this drawing is 10 feet, or 10 inches, or 10 centimeters, whatever measurement I had wanted to use. The area of a square is side squared. That's all that S means, the measurement of the side equals the area. So if they show you a square and they tell you that, they might even say this is a square, and they'll just show you the one number 3, you need to realize that you're putting the number 3 in the place of the S, but you are squaring it. So 3 times 3 is 9. So the area of this particular square is 9 square inches. It could have also been written as 9 inches squared with the number 2 up there. Okay. The area of a rectangle is very similar to the square. You're using the two numbers that meet at a 90-degree angle. So it's the length times the width. It doesn't matter initially whether you call this the length and this the width, or this the width and this the length, because multiplication is commutative. You can move them back and forth. So the area of a rectangle is the length times the width. You plug in the numbers they've given you, and you get 2 times 4 is 8, and it becomes 8 square centimeters, or 8 centimeters squared, just like I showed you on the previous square. Because it actually creates small squares inside. Here we go. So now you can see I've got 1, 2, 3, 4, 5, 6, 7, 8 squares inside of this. That's how you get square centimeters, or square centimeters, or centimeters squared. Area of the triangle. The formula is 1/2 the base times the height. So you'll have to look at the triangle. They'll usually give you this information. Later on, they'll give you formulas to figure it out if you aren't given the information. But the number that meets at the right angle are the two numbers you want. This is the height. This is the base. So on this one, we will plug in, we keep the 1/2, and we want to multiply times 2 times 6. We do not want to use the 3 and the 5 because they are not the height or the base. The height and the base always meet at the 90-degree angle. So now I need to multiply. I can just put these fractions up under there. I can go straight across, or I can look to see what I can cancel out. That's the quickest. So I'm going to cancel this 2 and this 2. I just divided by the number 1, and the answer becomes 6. And because I was doing area, my area is still square feet or square inches or whatever I am dealing with. So it could be feet squared or centimeters squared. The volume of a rectangular solid is length times width times height. That's the formula. So you look at the picture and you see what numbers they've given you to coincide with these parts of the triangle. And notice all of these measurements need to meet at a 90-degree angle. So you would just plug in the numbers. So if I said that the L equaled a 2, and the W equaled 5, and the height equaled, let's say it's 3. So then I just go and plug them in. And I don't need to worry about the order because it's all multiplication. It's commutative. So I'm just going to put 2 times 3 times 5. Well, 2 times 3 is 6, and 6 times 5 is 30. And it's 30, but now here is a distinction from what we had before. The 30 becomes cubic feet or inches. It could also be feet cubed or inches cubed. And it's because this is a three-dimensional object. It is creating not just flat squares, which I would get if I just did the front face, but it's creating cubes, just like on a Rubik's Cube. Okay, the volume of a triangular prism, same type of idea, but you have to start with the formula they give you, which is the capital B. And the capital B is representing the area of the base. So this capital B is the area of the base. And in this case, the area of the base, the area of the triangle, because there are a base here and a base down there. You can barely see it. And then I can, kind of put my dotted line. Okay, the base is the triangle since there are 2, 1 on each end. Then we want the height, which is the length of the rectangular face. So the length of my picture here is a 6. I didn't write that very well. Okay. So we want to plug it in, which is I've done down here. And we've got the base times the height. Well, the base needs to be the area of a triangle, which is 1/2 the little b times the height. That's the base times the height. This big B, capital B, is the area of the base. Be careful. So I will plug in my numbers that I've got. So for the triangle, I've said that the height was 3 and the base was 2, so I've plugged them in. I got half of the number 6, that's what's happening here. Half of 6 is 3, and this was another 6, excuse me. I left something out. So 3 times 6 is 18. And it's 18 inches cubed. Area in general. Here's a picture you might see. This could be figured out in 2 ways. 1, I need to take the length times the width, or the width times the length, either way. So I can do 3 times 2 plus 6, that's what's being shown right here, and I hope you recognize and realize that this is the distributive property. So I could also, because it's the distributive property, I could also be saying 3 times 2 plus 3 times 6, and that's what's happening here. 3 times 2 plus 3 times 6. And you could also see that more because this is also the number 3. Even though they didn't give it to you, you should realize that. So one problem is 3 times 6. Another problem is 3 times 2. But then you need to add these two things together. Surface area. Get the area of each face and then add them all together. Well, I can see this face on the front here is 2 times 3. But there are 2 faces, one on the front and one on the back. So when I did this, I got 6 times 2 gives me 12. Now I have another face that is this bottom piece right here. That's 2 times 4, but that's the bottom and the top. So that's why 2 times 4 times 2 gives me 16. And then this face right here is 3 times 4, and that gives me 12, but there are 2 of them, this one and the one on the back side. And so 12 times 2 is 24. And now we just add all the faces up, and that gives me the total. And because they were flat faces, it becomes square, because it's just area, not volume. If they had wanted the inside of this shape, I would have used just the 2 times the 3 times the 4. Probability. Always put the possible outcomes over the total amount of outcomes. So you've always heard of probability when they have the socks in the dryer, and what's your probability of getting out a particular sock? So here's an example. There are 2 blue socks, there's 1 green sock, and there are 3 red socks. And they'll say, what are the chances of picking a blue sock out of the dryer? Well, how many blue socks did I have to begin with? I had 2. So I put that in the numerator. That's the possible outcomes. I can only ever get 2 blue socks. But how many socks were there altogether? I have 3, 4, 5, 6 socks. So you want the total socks in the bottom. And then you always want to simplify. So I have my 2/6, and it reduces down to 1/3. I have divided them both by 2. 2 goes into 2 1 time, and 2 goes into 6 3 times. So therefore, I have a 1 out of 3 chance of picking a blue sock. If you are presented with a number line with fractional parts, you'll see something like this, and I've given all sorts of letters here. I want you to always put the part over the whole thing and reduce it. And that was very similar to what we just did with the probability. Get in the habit of always putting the part over the whole thing. So they say, and then if we want to figure out what fractional part, suppose they say to us, what fractional part is associated with the letter C? So I will count the marks, not starting with 0, because you never start with 0. Count with the very first one. 1, 2, 3, 4, 5, 6, 7, 8. Go to the whole number 1. Okay? So I had 8 marks. That means that's my denominator. That was the whole thing. So then what one did I land on when I was at the letter C? I was at 1, 2, 3. So 3 is my numerator, and 8 is the denominator. And then you look to see if you can reduce it, and I can't reduce it. Let's pick another one. I want to pick this D right here. So I want to count over 1, 2, 3, 4. That's my numerator. And then how many did I have altogether? That never changed. I have 8. So then I want to look and say, can I reduce it? And yes, 4 can divide into both of them. In fact, 4 is the greatest common factor. So 4 goes into 4 once, and 4 goes into 8 2 times. And that is how we simplify that. So the letter D is associated with 4/8, but we would always call it 1/2, because you always want to simplify. So always just put the part where you are, this is the second one, over how many you had to begin with, which was 8. So 2 8s reduces to 1/4. So that's the same as that. Okay? If you are presented with, say, a square or a rectangle that's divided into pieces, and they ask you what fractional part is shaded, count the shaded pieces, put that in the numerator, count the whole thing, including the shaded pieces, and put it in the bottom. So I'm going to count